Okay, we're now into the third video. We're getting into the properties section of the study guide. For problem number 8, we know that the integral from a to b of f is 5, and the integral from a to b of g is -1. We're asked which must be true. Okay, so we have to go with our 5 properties that we know about. Okay, for starters, we know that we can, in fact, add these two. We can also subtract these two. So if f is 5 and g is -1, f plus g equal to 4, that is definitely true, okay, because we're allowed to add. All right, so that means that a is out and c is out. Now we look at number 3. Well, this says f times g is -5. And yes, 5 times -1 is -5, but our properties do not state that multiplication definitely will be able to be split up. All right, addition, yes, that will work. Subtraction, yes, it'll work. But multiplication and division may not necessarily work and likely will not work. So this is not true. So 3 is out, which means D is out and E is out, and our answer is going to be B, number 2 only. Just going back here real quick, this is similar to the problem from the homework. F is bigger than G. Is that the case since the area under F is 5 and the area for G between G and the curve is -1? Does that mean that F is always greater than G? And as we noticed on the homework, that is not necessarily the case. So that one also might be true. It probably is true, but it doesn't have to be true. All right, problem number 9. This one's as easy as it seems. All right, the values for k for which this definite integral will be equal to 0. And yes, if k is equal to -3, all right, that is definitely true. So -3 has to be in the answer. That knocks out 0 and that knocks out 3. So we got these 3 options right here. Now, if we draw a quick picture, all right, we know that we are looking at the graph of x squared. All right, we're interested when the graph, when the area will be equal to 0 between the curve and the x-axis, beginning with x equals -3. Now, if we include 0 at all, well, the area from -3 to 0, that is definitely positive. That's not equal to 0. There's some area right there. So 0 can't be involved. Now, what about if we go from -3 to +3? Well, again, there's some area there, okay? So that is not 0. So that's out as well. The reason why they put these confusers in is because if we have a situation like so, where we have the function x cubed, okay, well, now the function x cubed from -3 to 3, this integral would be equal to 0. All right, the integral from -3 to 3 of x cubed dx. All right, that is equal to 0. Why? Because the area under the curve mirrors the area over the curve, and they wipe each other out. A negative times its positive mirror will be equal to 0. That's not the case with x squared, though. X squared, the only value is whatever a is, happens to be at both the top and the bottom bound. Okay, number 10, we see the integral from -5 to 2 of f of x is equal to -17. Okay, that's fine. We also see the integral from 5 to 2 of f of x dx is equal to -4. Hopefully this triggers your spidey sense. You should see this here and say, wait a minute, the bounds are wrong. All right, we need the lower bound to be down at the bottom, all right, and our higher number is our upper bound up top. We need to swap the bounds, and we're allowed to do that as long as, oops, where's my dx? There we go. As long as we negate our integral. So what was -4 is now 4. So the integral from -5 to 2 is -17, and from 2 to 5, it will be 4. All right, now we are asked what's the integral from -5 to +5 of f of x. Okay, well, this goes back to the whole is equal to the sum of its parts. The integral, I'm going to write shorthand here, the integral from -5 to 5 of f is equal to the integral from -5 to 2 of f plus the integral from 2 to 5 of f. Well, -5 to 2 is -17. 2 to 5 is 4. And our answer, when we put them together, is negative 13. There we go, B. With our final property on this page, the integral from 0 to 1 of f is equal to 2. The integral from 0 to 4 of f is equal to negative 3. We're asked about the integral from 1 to 4. Okay, so this is actually, let me slide back down, similar to a problem over here. We've got to break up our bounds, all right? The integral from 1 to 4 of f will be equal to the integral from, the integral from 0 to 4 of f will be equal to the integral from 0 to 1 of f plus the integral from 1 to 4 of f. All right, wherever we leave off, we have to pick up. All right, so 0 to 1 of f is 2. Okay, 0 to 4 of f is negative 3. So negative 3 equals 2 plus our unknown. Right, what does x have to be? Well, subtract 2 from both sides, and x has to be negative 5. All right, so what does that mean? That means that the integral from 1 to 4 of f of x dx is equal to negative 5. Now we're asked to find that integral right there. So let's break this integral up. We have the 3 as a coefficient, so that can move out front. And we're adding, so we're allowed to break that up into 2 integrals. Okay, so 3 times f of x, 3 times negative 5. There's our negative 15. And remember, this is not going to be plus 2. We have to take the whole area. If we were to put 2 here, 3 times negative 5 is negative 15, plus 2 is negative 13. Remember I told you option A is always going to be that incorrect one, but we don't want plus 2 here. We want 2 times the range. The range is 4 minus 1. The range is 3. 3 times 2 means we're actually adding 6. So we have negative 15 plus 6. We want negative 9 as our answer.